Hey everybody, Alex Miller at Capneon here. Now, if you're actually bothering to listen to the audio on this video, you might be one of these people who's a little bit tired of Google knowing when you go to the bathroom. What do I mean by this? Of course, everybody's carrying around a smartphone these days, just maybe in your pocket all day when you're at the office or at home. And depending on how you got your permission set up, your phone might be telling Google or Apple or somebody similar where you all are all day, even when you're in your own house. And this is a little creepy, right? But then on the flip side, there are some cool services you can get by providing this sort of location data. You know, what's in my area that I might be interested in doing, etc. There's value to the consumer here. And I want to talk about ways you might be able to have your cake and eat it too. I'm going to go into an example of using Ghost PII to do some work with location data. And the point is that we can get some circumspect, useful insight from a data set describing where people are, but then we don't actually have to move the data set around wholesale to spy on people when they're not doing something relevant to our actual business need that might actually be welcome and beneficial to the consumer. So check it out. All right, I want to start out by pointing out real quick, this is a Jupyter notebook. It's something a lot of people who work with Python will be familiar with. We are all about making this technology accessible to people who already know how to use Python and don't want to have to learn too many more new things. Ghost PII is really a piece of Python middleware and a API service that supports it. So here we're going to import Ghost PII on the client side. This is essentially a special key hosting service that it's going to talk to. But once we've set these things up, and this is pretty standard import procedure, we're not going to have to think about it that much. This is your standard post-2020 obligatory COVID contract tracing example. And the point here is we've got a list of people and where they are at different particular times. And we want to check, maybe one of these people had some scary disease. We want to see who they might have come into contact with and warn that person. And then we want to be able to do this in a way that we don't have to learn everything about everybody else's business. Of course, the point of what we are doing here is that we're not actually going to work with this plain text data. That's just for you, the audience, to try to get some intuition for what's going on. The point is exactly that we're going to encrypt it, and then we're actually going to work with the encrypted data. So you wouldn't normally do this, but this is actually what's inside the data object we're going to use. And the point is that it's very difficult to backdoor this into this original data here. But then down below, we're going to analyze it just like you would analyze regular data. So this is the Euclidean distance. We're going to use a data set here where all of the observations are relatively close together. And if you forgive me, we're going to ignore the curvature of the Earth. So we're just going to see when is the distance between one chosen person and another really small. And then once we've identified those matches, we can send them to somebody else in our flow to take some kind of action on them. But then the privacy of everybody who doesn't have a scary disease and didn't run into anybody with a scary disease is protected entirely through the process. And then that's what we're doing right here, of course, is checking out what are those matches. You run this code, and once again, this is pretty familiar looking Python code to everyone, I hope. It's going to talk to that API I mentioned, and it's going to use that to just construct essentially how close everybody was at different times. And it's going to go through, and it's going to, at the end, it's going to spit out what were the actual contacts. In this case, Alice and Carol got dangerously close to the COVID carrier. And so maybe we would want to pass that on to somebody else to get in touch with them, say maybe you should get a test. We didn't learn anything about anybody else's business because, once again, while this is the data that maybe is underneath, we were able to do this analysis with just this gobbledygook encrypted so that we can't get anything out of it, but what we have permission to do in the API here. So in the background here, implicit is that we have a flexible permission system and a unique ability to let you decrypt some follow-on computations and not others. And that's going to allow you to regulate that people get just the insight about the data that they're supposed to get and not more. And keep a lookout. That's something I'm going to talk more about in the coming weeks.